Okay, ladies and gentlemen, so what I'd like to do is show you how to label different types of angle relationships when we have typically parallel lines and an intersecting line, which we call transversal. So here you can see I have two parallel lines with a transversal. However, we're just naming angle relationships. We're not We're not actually talking about what those relationships are or how those relationships could be useful. We'll do that in further videos. So for right now, we're just kind of looking at where the placement is of our two kind of lines, and then we have this one intersecting line, which we call our transversal. So as right now, even though these lines look like they're going to intersect as they continue, we don't know that. We don't know if they're parallel or not. We are just looking at the angle relationships and labeling them. And there's 6 basic relationships that you're going to see when we have two lines and a transversal. And the first one is consecutive interior. So, when we think of like interior, you think of interior and exterior. And the way that kind of interior is explained is between your two lines, the interior is going to be the angles that are inside, like facing kind of each other. So you can see these interior, you can see how 3, 4, and 5, and 6 are kind of all facing each other, where 1, 2, and 7, 8 have nothing on the x, right? Nothing like containing them, right? But 5, 6, and 3, 4, they kind of like face each other. Same thing. So here you can see the angles are exactly the same. I just made sure I did parallel lines here and made sure I didn't show parallel lines here. But you can see 3, 4, 5, 6. So consecutive interior are going to be inside angles, but that are on the same side of the transversal. So the transversal is going to be the line that intersects your two lines, parallel or not. And if they're on the same side, they're what we call consecutive interior. So I'm going to say angle 3 and angle 5. Those are going to be consecutive interior. And also, we could say angle 4 and angle 6. OK? So those are also going to be consecutive interior. For the next one is, let's get into, actually, let's continue on alternate interior. Let's continue on interior. So we have the idea of interior, right? So if they're consecutive interior, that means they're on the same side of the transversal and they're both interior. Well, alternate interior is basically saying, well, they're going to be interior again, but they're going to be on opposite sides, alternating, like one's on one side, one's on the other side. So their alternate interior is going to be angles that are again on the interior, but now they're on opposite sides of the transversal. So instead of 3 and 5 are consecutive interior, 3 and 6 are alternate interior. Angle of 3 and angle 6 are alternate interior, and angle 4 and angle 5 are alternate interior. The next one is, now let's go ahead and explore exterior. So we talked about the interior. Those are going to be angles that are facing, kind of the interior. The exterior then are going to be angles that are kind of on the outside, right? So you can see purple is kind of on the inside. Orange dots are on the outside. So since these angles are on the outside, there's no kind of constraints. We call them the exterior angles because they're on the outside of the two lines, parallel or not. But they're not dealing with the transversal. So alternate exterior, if you look at alternate exterior, are going to be two angles on the exterior, not on the same side, but that are on opposite sides. So we could say that angle 1 and angle 8 are alternate exterior, as well as angle 2 and angle 7 are alternate exterior. OK? Now let's go and take a look at corresponding angles. So corresponding angles are going to be angles that are in the exact same kind of position. So it kind of looks a little bit confusing with this one. So it's a little bit easier. I'll just kind of use this with this angle here. So if you look at like this angle 2, right? If we want to find a corresponding angle to it, that means an angle that looks exactly the same or is probably like the exact same measure. You can see that, like, all right, here's the way I think about it. Let's think of like northeast, southwest, right? So let's kind of make a box. So if we were to say, this angle number 2 is in the northeast section of these kind of quadrants, right? Or you could also think about it's like in quadrant 1. So that's that angle. Well, the corresponding angle is going to be in the exact same position as the other one. So you can see that those are both, like if we were to make it kind of like a quadrant system, you can see that those are both in quadrant 1, or both in the northeast side, or northeast side of everything. So therefore, corresponding angles are basically angles that are in the same position. So it's a little bit more difficult to see here, but you can see that those two are both in that that upper right-hand corner. So angle 2 and angle 6 are corresponding. We could also do angle 4 and angle 8 are corresponding. And then you just kind of continue. Angle 3 and angle 7, angle 1 and angle 5. Angle 3 and angle 7. And then angle 1 and angle 5. OK? So all of these kind of deal with interior and exterior. These just basically compare with angles that are like in the same position with each intersection. Because when the transversal intersects, you basically kind of create a little quadrant system. The angles are going to be in the same type of quadrant as the other ones. Now, vertical angles we've kind of already discussed. But if you didn't watch that video or you kind of forgot, remember vertical angles are just angles that are directly across from each other. So whenever we have intersecting angles, or intersecting lines, we create vertical angles. So this transversal, you have two lines that are not intersecting, and then you have this nice transversal that intersects everything. Once you create an intersection, you have angles that are opposite of each other. Now again, remember for vertical angles, they can share a vertex, or they share a vertex, but they do not share any sides. So what you'll notice here is angle 2 and 3, they share a vertex, but they don't share any sides. So angle 2 and angle 3 are vertical angles. Angle 1 and angle 4 are vertical angles. Down here, we have 5 and 8 and 7 and 6. So angle 5 and angle 8, angle 7 and angle 6. And then last but not least is going to be a linear pair. Again, that's kind of something that I went through, but I'll happy to go through it again. Linear pair are going to be two adjacent angles. So when they're adjacent, that means they share a side. So 1 and 2 are adjacent angles. And not only are they adjacent angles, but adjacent angles that also are supplementary, meaning that they add up to 180. So there's quite a bit here. You could see, and the easiest way to know if adjacent angles are supplementary is if two angles add up, make up a line. So you can see that angle 1 and angle 2 make up a straight line. So therefore, they're a linear pair. So we'd say angle 1 and angle 2. You could do angle 1 and angle 3. You could do angle 2 and angle 4, because those make that vertical line. And then you could do 3 and 4. Angle 3 and angle 4. Right? So there's 4 different sets of linear pairs just in that one intersection. Let's do the other one over here. We'll do angle 5 and angle 6, angle 5 and angle 7, angle 7 and angle 8. Oops. And then we have angle 8 and angle 6. OK, so what is it important about? So now that I've labeled everything, when we have let's talk about that. That's just labeling. We'll talk about parallelism in the next couple of videos. So there you go, ladies and gentlemen. That is just labeling your different types of relationships when you have two lines and an intersecting transversal. Thanks.